welcome everyone here to Data Virtualization, bringing the power of FME to any application. Today, I'm joined by both Dawn and Sinai as our presenters. I'll pass things over to Sinai to introduce yourself.
Hi, everyone. My name is Sinai Mendoza. I've been at SAFE for about 5 years now, and I am a customer solutions specialist.
Wow. Yeah. And I'm Dawn. I've been here since, I'll use an old joke from a co-op student, since the dawn of SAFE. And yeah, so I get to work with amazing people and like Elizabeth and Sinai. So yeah, so welcome everybody.
Fantastic. We also do have Rylan joining us on the back end here today, supporting with questions. So if you do have any questions at all during the webinar, please don't hesitate to leave those in the questions tab. And Rylan will be keeping an eye on those. And then as well, we will have some time remaining at the end to address some questions live.
Nice.
Yeah. If you are newer to the Livestorm platform here, just a few tips and tricks. If you have any audio issues, you can click that help button on the bottom left for 4 simple steps to take. You can share your emoji reactions with us during the webinar. We love to see those with that react button on the bottom middle.
Mm-hmm. Yep, the presenters really love those. We really love to see the emojis. It keeps us, it's like fuel.
And then we know when you're actually laughing at our jokes and such.
Yes, exactly. And it's not just me laughing at my own jokes.
Yeah, awesome. And then, yeah, the questions tab. So just once again, any questions, don't hesitate to put those in that tab and keep letting us know where you're tuning in from with the chat. All right, so from here, I will prompt our presenters if we can turn off our webcams just to save on some bandwidth for the remainder. And I will pass things over to Dawn for our agenda.
Yeah, thanks so much. And so this is, I'm not going to go through all the items, we'll see it, but this really is, oh, you've heard about data virtualization. You want to see how to get started. And so that's what we're going to do. We're going to walk you step by step through so you can get started with data virtualization. And there's nobody better to do that than Sinai. She did a training course already at the peak, and it's amazing. So we're just going to boil that down to just the very basics. And so when you leave, you'll be able to try data virtualization yourself. So that's the goal. And a quick introduction. So what data virtualization is all about is enabling you to get access to your data in real time through a secure OpenAPI layer. We're not duplicating data. We're giving you direct access to data. You can think of it as FME data virtualization brings the power of FME to applications, like FME apps brought the power of FME to users through web browser. So yeah. And really, it's a method where you can define this layer, hide all the intricacies of your data fabric underneath, and present a really nice, clean layer to your organizations in a safe and secure way. Some of the things that organizations are frustrated, if you're building an application without data virtualization, often you have many siloed systems, so your application is going to have to know how to authenticate with each of them. And maybe you're going to move some data, maybe you're going to create a data copy. And both of those have really things that are complicated, they delay you down, and you're not seeing your data live the way it is. So I'm sure many of you have experienced what it's like trying to build an application on top of many systems. With data virtualization, all that you deal with once as you're building the data virtualization layer. And now you have a really clean, OpenAPI compliant REST interface with which to build applications. And so, yeah, so you don't have to like wrangle data manually or wait on your IT time. Once you have that data virtualization layer, you're really free to empower people to get access to the data that they need when they need it. You're also, you can sleep at night knowing that the only people who have access to the data are going to get access to the data. It doesn't matter what application they're writing, they're not going to be able to get access to data they shouldn't otherwise have. And so, yeah, so really live data access, which is really key. It's also important to note that this is CRUD. So you can create data, you can read data, you can update data, you can delete data. It's not just a retrieval mechanisms, it's full-blown REST capabilities And so, yeah, simplified data views bring multiple systems together, show the applications so you can build dashboards to a really nice, simple way of looking at the data, not having to deal with the complexities underneath. And yeah, and of course, you can continue to grow it, add new data sources, because again, you're using FME's no-code interface to really empower and build these interfaces. Here's our platform as we defined by what we announced at the peak. So we have FME Form. And again, with everything, this is where it starts. So all your data virtualization work starts on Form. So you don't have to learn anything new. If you know Form, you're able to build data virtualization. And then Flow is where the data virtualization is hosted. And so on the left tab there, now you'll see data virtualization where you define exactly what your API looks like and some of the characteristics of it. And on FME Flow. And of course, we have our SaaS version of FME Flow called FME Flow Hosted. And FME Realize isn't part of this webinar, but it is the thing that brings the power of spatial computing to the FME platform. And of course, one of our strengths is if there's data out there, we support it. If you come across any data source that we don't support, let us know. I see this one is we recently added graph data. It's not on here. So you can see that we all have trouble keeping up with how fast FME is moving, which is a good thing. And with that, I am happy to pass this off to Sanai, who's going to walk us through and just show us how easy it is to get started with data virtualization.
Thanks, Don. So, like Don said, instead of just explaining data virtualization today, we're actually going to show you how it works. So we're going to walk through real examples and demos so you can see it in action. And by the end of this webinar, you'll have everything you need to create your own API. So data virtualization, in theory, is just an approach to data management. But here's what it looks like in FME. FME lets you build REST APIs on top of your virtualized data. This means that other software and users can now access all the data and services that you have through a simple API request. They don't need to know where the data comes from or what it looks like. They don't even need to know how FME works. They don't need to download anything. They just make a request and get back what they need. So here's the idea in one line. FME connects to your data, shapes it, and shares it as an API. That's the whole workflow. So some of you might already be starting to see how this all fits together. If you think about it, FME already had everything we needed to build great APIs. It can handle the web requests, it can read and write data in hundreds of formats, it can transform and deliver the data however we want. So now with data virtualization, we can turn all of that into a live API. You're essentially adding an interface to what FME is already great at. So let's look at how this compares to some of the features we already know. Webhook URLs are simple and useful, but they're really just basic event triggers. There's not much room for customization. The FME Flow REST API is powerful for managing FME itself, but it's not really designed to expose your data or workflows to other systems. Data virtualization APIs fill that gap. They give you full control to build fully custom web integrations on top of your data. And it's equally important to know what data virtualization isn't. It's not just read-only, it can also do full CRUD operations. It'll be useful for organizations of any size, and it can scale with you. It's not an API gateway. Traffic, network control are totally up to you. And it's not a data warehousing strategy either. The overall purpose is to enable access rather than storage or networking. So what can you actually do with data virtualization? Let's look at some real-world examples. In our first scenario, the problem is legacy systems. They hold important data, but they're hard to work with. Sometimes no one understands how the system works anymore, or let alone the data. Migration can be expensive and risky, so lots of organizations just leave them be. But with data virtualization, we can connect directly to those systems and expose the data in a way that others can actually use. It acts like a translator, making that legacy data readable and useful with modern tools. And it does that all without breaking what already is working. Let's look at AI. Everybody wants smarter tools, but connecting to them with your data is hard. It usually takes time, custom code, and a lot of trial and error. With FME, you can expose your filtered data as secure endpoints that AI can query directly. We can even use FME's own AI tools. The data gets to stay where it is, private and protected. And finally, spreadsheets. A lot of teams still rely on Excel or something like that to track important data. But when that data needs to be used somewhere else, like a business process or web app, things start to break down. People are emailing files around, copying and pasting between systems. It's slow and error prone and hard to keep up to date. With data virtualization, we can treat these Excel files as live data sources. The web app can connect directly and update automatically, no manual steps needed. So let's see how this all fits together in a demo. So this is a simple dashboard built with HTML and JavaScript. It shows real-time emergency shelter data across BC. All of it's coming from FME's data virtualization APIs. So let's say I want to find shelters in the Cariboo. Our dashboard pulls all the locations and occupancy data for that region. And if we do another search, maybe this time for shelters with enough room for 21 people, the results update immediately. We know right away that some shelters might not have enough room. This is all powered by a real-time API call, filtered by region and minimum capacity. Even the contact information at the bottom is API driven. That's another call to an endpoint in FME. So let's take a look at the developer tools. We'll make another search to trigger a request. So you can now see an endpoint in FME Flow hosted show up on the side panel there. And we can see all of the live facility data come in. All of these endpoints are documented through an API documentation. So here's all the same endpoints our dashboard uses. Region and capacity are the same parameters that we used in the website. So let's test it manually. Here's the exact JSON returned, what the dashboard uses under the hood. So here's our API in FME Data Virtualization. No custom backend. This endpoint was created in FME Flow, and the workflow is authored in FME Form. And here's the actual workspace. Nothing fancy here, just reading from an Excel sheet and a geo package. So this combination of spatial and tabular data powers our live API and in turn our dashboard. So what you're seeing, the web app, the live query, the real-time filtering is all powered by a simple workspace in FME Data Virtualization. So every piece of that dashboard, from the table to the contact information, comes from APIs built in FME. It's fully documented, tested in Swagger, and powered by a simple workspace. Nothing but the front-end web page required any coding, and even for that, I could have used something out of the box. So over the next 30 minutes or so, we're going to build everything we need to set up a working data virtualization API. We'll start in FME Flow because this is where you define an API. Its endpoints, behavior, schemas, and security. Flow also generates the workspaces for each endpoint, pre-built to handle incoming requests. So Flow is the interface layer. It controls how the API looks and how users connect to it. Once the structure is in place, we move to FME Form to build what happens behind each endpoint. In Form, we're authoring the endpoint workflows, connecting to data, running transformations, and shaping the response. Form is like the processing layer. It powers the backend of each API call. So in a nutshell, Flow defines and exposes the API structure. Form builds the workflows that run behind those endpoints and handles the data. All data virtualization APIs follow the OpenAPI standard. This is a common format used across the web to describe REST APIs. That means that your APIs can be easily reused, extended, or imported into other systems. And with built-in Swagger documentation, they're ready to share with others right away. So OpenAPI makes it super easy to build workflows in other platforms. In FME, you can use the OpenAPI caller to connect and test with OpenAPI specs directly from your workspace. The HTTP caller is similar, and it gives you a bit more flexibility for other types of APIs. Otherwise, the Swagger documentation, a browser, or tools like Postman will also work. So we have two options for creating a data virtualization API. First, we could build it from scratch. This is best when there's no existing specification. Otherwise, we can import an OpenAPI spec file. This will set up the structure for you. This is great for migrations or when you're working with a shared definition. And in both cases, we'll still have to build the underlying workflows to power each endpoint. So before we get into our next demo, let's quickly cover security. You can control access at the API level or at the individual endpoint level. Permissions are based on roles and users, managed separately from other flow settings. Just keep in mind that FME Flow isn't an API gateway. Network security still needs to be handled on your own environment. Okay, so let's get to building our API. So in our first demo, we're going to import an OpenAPI specification file to create the structure of our data virtualization API. The goal of this API is to bring environmental and disaster data from multiple sources into one place. Okay. So to create an API, we begin by navigating to the new data virtualization section in FME Flow. Remember, we have these two choices for creating an API. The first option is to use a form to manually define the details. We won't today, but there is a tutorial on our knowledge base that walks through that process. For this demo, we'll import our OpenAPI spec file and create an API that way. So let's first review that file in a text editor so you can see what it looks like. Reviewing the raw JSON gives us an idea of how the API is structured, each definition, schemas, and data types. From this, we start to see a picture of our API for environmental data. And since it follows the standard format, we can use it to kickstart our process. So we'll find the file and just upload it to FME Flow. And we'll give the API a namespace that will become part of the URL. Once it's created, we're going to land on the API details page. Here we can configure metadata like summaries and contact information, or behavior like caching and asynchronous processing. And in each of these tabs, we're going to find different parts of our API. Lots of endpoints and their metadata, workspaces that have yet to be created, schemas and their data types. And in security, we can manage access at every level. We're going to disable authentication for this demo, but it's just always having it enabled, especially if your API is public facing or has sensitive data. So to see our API from a user perspective, let's open up the Swagger documentation. Here we can expand each endpoint and see all those same parameters, expected responses, and data structures, this time in a public facing documentation page. This makes it really easy to share all your services with your team or publish it for public use. OpenAPI compliance means we can also export API definitions from FME Flow. So we can share these files with other users or import them into other apps for workflow development. So in FME Workbench, we can read in this specification file with the new OpenAPI caller transformer. This saves a ton of time by importing all the pre-configured API requests into the workspace. You can even test out requests and change all the parameters directly inside the transformer. So there's so many apps out there that you can work with OpenAPI, so it's really up to you. We can import it into a third-party app like Postman. Again, this just saves a lot of time and makes it easier for you to collaborate. And here's all our endpoints. But if we were to send a request to any of these endpoints right now, they would fail because we've just completed step one of the process in API creation. So we've created the basic structure of the EnviroData API. The endpoints and schemas are all in place, but there's no data flowing yet. This API definition is just the scaffolding. It sets up the framework, but it doesn't include any FME specific parts like workspaces or data sources. We're going to take care of that in the next steps. So the next step is to create and configure the endpoints. A data virtualization endpoint defines how users interact with your data through structured API requests. Everything about the endpoint can be customized. Some endpoints will return live data, others can just return static data. It's entirely up to you. So all endpoints are initially created or imported in FME Flow. So that includes all the methods and status codes, parameters, and behaviors. This is the first step. What sets endpoints apart is how they generate their response. So when creating an endpoint, we choose between two response types, manual or workspace. Manual responses always return a fixed static result no matter what the input is. So they're useful for simple things like a metadata or status check. They're built entirely in FME Flow and they don't use a workspace. Whereas workspace responses work differently. They're dynamic. They run a workspace every time a request comes in. That means that the output can change depending on the request and the connected data. They're great for dynamic inputs, real-time queries, integration with external data sources, anything that depends on live data. So even though manual and workspace endpoints look similar on the surface, the key difference is how they behave behind the scenes. Manual is static and workspace is dynamic. So if you need flexibility, use a workspace response. It supports parameters to control how the request behaves, all of the methods, and can return different statuses based on the result. These endpoints are really powerful because they connect directly to an FME workspace. When a request comes in, it triggers a job in FME Flow. The engine runs the response, processes the data, and returns the result back to the client. Since the workspace runs at request time, the data is always current. This approach gives you full access to all of FME's transformation capabilities just through simple API calls. So now that we know how they work, how do we actually build one? There are three main steps to authoring an endpoint. First, we define the endpoint and generate a workspace in FME Flow. Next, you download the workspace into FME Workbench, where you can build out a workflow just like any other FME process. Finally, you publish that completed workspace back to FME Flow. And at this point, the endpoint is ready to handle live API requests. So let's start at the top. We'll go back to that slide on defining endpoints in Flow, this time thinking about the response workflow. Every parameter and status code and schema we define are going to show up as inputs in our workspace. So that means that the request data controls things like the queries and filters and outputs. So we can also plan for different outcomes, like returning a specific message when something goes wrong. So you might think of the endpoint metadata like the server who takes your order. The workspace is the kitchen that prepares the dish, and the response is the meal that gets served to the client. And in addition to endpoints, I also wanted to highlight schemas because schemas define the structure of the data used in both the request and response, things like required fields or data types. If the API is the restaurant, the schema is like part of the menu. It tells the client what they can order and what it should look like when it arrives. This makes the API easier to understand and use for both sides. And you'll find schemas throughout the entire authoring process. So first we can define them in FME Flow and assign them to your endpoints. They're also in the API documentation, telling users exactly what to send and what to expect in return. And they carry through to your workspace where they can shape the reader and writer. Basically, schemas are the thread that keeps everything aligned. Once our endpoint metadata and schemas are defined, we can generate a workspace. And in data virtualization, Flow does that for you. You choose one or more endpoints, and Flow creates a workspace wired with all the correct parameters and structure. Every workspace has a status telling you where it is in the authoring process. Once a workspace is generated, your work in FME Flow is complete, and the next steps take place in FME Workbench. When you download an endpoint workspace from Flow, it begins as kind of a template. It includes a pre-configured data virtualization reader and writer, and at this point, the workspace is just a framework. The wiring is all in place, but all of the logic and transformations and data handling are up to you. So the data virtualization reader and writer each serve a specific role. The reader maps the incoming API requests, and the path and parameters become attributes. If there are multiple endpoints in a workspace, each has its own reader feature type. The writer maps the API response with attributes for status codes, headers, and response bodies. Both the reader and writer are generated by Flow and can't be edited directly. They'll update automatically when you edit the endpoint in Flow. So in a data virtualization workspace, our goal is to handle the requests and prepare the response. So this means using endpoint parameters, shaping the data to fit the response schema, and routing to different status codes. And in the end, our outputs are the building blocks of our API response. So once you've built a few of these endpoint workspaces, this process will start to feel really familiar. If you remember picking up automations or flow apps for the first time, it's the same idea. After a couple of workspaces, these patterns will become really clear. So here's a quick summary of common tasks and useful tools for building endpoint workspaces. Beyond the basics, you'll want the request to stay as lightweight as possible. So lean in on FME best practices, things like filtering early, ideally at the source, leveraging SQL, just lighten up your features wherever possible. The cleaner your workflow, the faster and more reliable your API will be. So before we jump into our next demo, you might be wondering how we test API endpoints in FME Workbench. Since we can't send a real API request to a local workspace, we're going to use input templates instead. These are JSON files that simulate an API request. We just fill them out with test values to run our endpoints locally, and you can save different templates as samples to cover all your various test scenarios. With that, let's get into building an endpoint. So in this demo, we're adding a new GET request to the EnviroData API. It will return live evacuation facility data during an emergency. The goal here is to give people fast, reliable information, whether they're residents or businesses or emergency services. But right now, the data is split. One source is a government GIS with facility locations, and the other is a folder of Excel files manually updated by the staff at each site. We don't want the public checking both sources during a crisis, and we don't want to give them too much information. So we need a way to bring the data together and make it easy to access. That's where data virtualization comes in. We'll build an endpoint that connects both sources and returns one clean data set. So we're going to begin this demo not in Flow or Workbench, but in FME Data Inspector. Our first data set is our geo package that holds the evacuation locations across British Columbia. And we'll need to turn this point geometry into information that we can share in an API response. Our other data source is our folder full of Excel spreadsheets, one per BC regional district, at least a sample. These contain live site information like remaining capacity and contact information. Notice that there's potentially sensitive information in here, so we'll want to filter that out. Our goal is to transform these data sets into something that can be shared with the public. So we'll begin authoring our API endpoint in FME Flow by opening up our EnviroData API. And we'll start in the Schemas tab. We'll select the facility schema that was imported by our OpenAPI spec file. And I'll add a couple of fields like facility name as a string and remaining as an integer. It's easier to build a workflow when you know what the data should look like. That's why we start with schemas. They define the shape of everything that will follow. So with the set schema, we can move on to the endpoints tab. And we'll create a new GET endpoint called facilities. And its description and summary will be in the documentation so that the end users can understand how to use the API. We'll organize it under the services tab so that they can find it. In our response tab, we'll choose the workspace type because we're working with live data sources. And we'll set up two status codes. First, 200 for a successful response. And since we expect good data to be returned to the client for this, we'll use the facility schema as a response. We'll also create another status code, 204. This is for when no matching records are found in our data sources. This will help the client troubleshoot when they're not getting the expected results. Now that our endpoint metadata is defined, we can save it. And we'll move into the Workspaces tab to generate the workspace that powers it. In our Workspaces tab, our endpoints are listed, but all of them are unassigned. So we'll select our facilities endpoint and generate a workspace. And we'll update it to a more descriptive name, like facilities. And once we hit generate, FME Flow has automatically created a workspace, which we can see listed next to our endpoint. We can also see that the workspace status is now needs authoring, which signals to us that it is incomplete and needs to be authored. So to do that, we'll move to FME Workbench. And here we're using the new Data Virtualization wizard to download the workspace. When an API is selected, it shows all the available endpoints, including the one we just created. We can also choose a directory that saves all of our API resources for local development. And when we open the workspace, we see our new Data Virtualization reader and writer. The reader has just one attribute that represents the request, and on the writer, we see the attributes that make up parts of the API response. And we'll start by building the workflow that creates our successful response, 200 OK. So we'll add some feature readers. And our first feature reader loads in all the Excel spreadsheets. We use a wildcard in the path so that it reads every file in that directory. We'll only select the fields needed for the response, excluding anything sensitive. And here's our second feature reader that reads in the geo package. A where clause only reads in the locations that are found in the Excel sheets. So at this point, we could probably run the workspace to confirm that we're connected to our data sources. And running the workspace launches this window for endpoint testing. Our request is simple, so we can just run the template as is. So in our feature caches, we can now confirm that both data sets have been read and combined. And our next major step is to format this data for the API response. So our GIS is giving us spatial features that don't translate well to an API response. So we're going to use the geometry extractor to convert the spatial features into GeoJSON attributes, but this could be any encoding. Next, we'll use the JSON templater to structure these attributes into a JSON format. And the subtemplate transforms every record into the facility schema that we defined earlier in FME Flow. And on our root template here, we're just wrapping everything in an array. We'll change the result attribute name to response body content, since this is what our data virtualization writer is expecting. And we'll add another tester just to confirm that array isn't empty. Finally, we'll finish off this 200 status code workflow with an attribute creator. It creates two key attributes for the writer, the response code and the data type. Now, if we check the writer, our response attributes are going to show up as green, or at least most of them, meaning that we've created everything we need for this endpoint. But before we publish, let's do the same for the 204 status code. 204 is when the workspace doesn't find any data. So for that, we can use a tester transformer just to confirm if the Excel spreadsheets return data. And if there's no data, another attribute creator will create the 204 response attributes for that writer. So now we have two status codes. Let's test the entire workflow. Running a data virtualization workspace locally saves the response to a file. So the first thing we do when we run the workspace is just choose a local directory to save it to. And then we hit run like any other workspace. And we'll go find our written output file in that directory. I can show you what that looks like. Here we have it, our 200 status code and a formatted JSON list of facilities. That confirms that our endpoint workspace was successful. At least it is in Workbench at this point. So we can publish that workspace back to FME Flow. And back in FME Flow, the first thing we're going to do is check the workspace status. And we can see it's now assigned. However, this doesn't guarantee that it's going to return the expected results. And for that, you need to make an API request. So back in our documentation, we'll try out this request. And a 200 response with all of the facility records confirms that our endpoint workflow was successful. This confirms that FME Flow executed a job, read in the data, and formatted the response just like we designed. And that is how you create an endpoint in data virtualization. We now have a live endpoint built with FME Flow and Workbench. We've created the workspace, connected the data, and set up the response, then published it. That covers everything you need to know for building a working endpoint in data virtualization. But since we have a bit more time, let's keep going and look at what else is possible. So all aspects of API design will affect your user experience. It's not just about making the data available. Data virtualization really improves on how users and applications interact with it. When you add parameters and validation, error handling, your endpoints become smarter, faster, and more reliable. All of that matters if you want your APIs to scale and hold up to real world use. Parameters are the simplest way to make an endpoint more dynamic. They let users control what they get, like filtering by date, sorting, or eliminating results. We support all data types, so path, query, and headers each serve a different role in a request. And with parameters, the key is to filter early and filter smart. So use the reader query options first, where clauses, select statements, or spatial filters. Transformers like the inline querier, SQL executor, also will offload filtering to the database, making things just run faster. So tools like the tester and sampler work as well, but they will run after the data loads, so that can add overhead. Just be mindful of that. In our next demo, we're going to update our facilities endpoint just by adding parameters. And to do that, we're going to go back to our authoring process. There's a few common reasons you might update an endpoint or workspace. That's adding parameters, fixing logic, updating schemas, or linking another endpoint to that workspace. And when that happens, the workspace status will switch to needs updating. That's your cue that the API definition and the workspace are no longer in sync. So next, you'll update or re-download the workspace in FME Workbench. The reader, writer, and templates will reflect your new endpoint metadata. Then we'll update your workflow and publish it back to FME Flow. So let's update our facilities endpoint by adding in some parameters. Where we left off, our facilities endpoint returns the data for every single region. We will give it more flexibility by adding 2 parameters. First, a path parameter will let users filter by region. Second, a query parameter will let users filter by remaining capacity. These additions will help the public or any public services quickly find evacuation facilities that are nearby and open. Okay, so we will return to our API in FME Flow and open up the facilities endpoint. Right now, it returns the results from all regions. So to make it more flexible, we'll update the endpoint path by appending a parameter called region. And enclosing the name in curly braces creates a path parameter, which we can see here. And we'll also add a query parameter called minimum capacity to let the users filter their results by the number of available spaces left. So if you're looking for a facility with room for a group of 10, you can easily filter those results. Before saving, we'll go into our responses tab because now that we have user inputs, there's more potential for error. And we can add a new status code called 400 bad request. And this will have a descriptive message, bad parameters, so that the end user or application can fix the request before trying again. And once we save an endpoint that's already created, FME reminds us to update the workspace connected to it. We can go over to our Workspaces tab and see that the status is now needs updating. So let's go over to FME Workbench and update it. So you can update a workspace by re-downloading it, or you could update the reader if it's already open. Once opened, we can review our new attributes on the Data Virtualization reader. We now have path region and minimum capacity, just as we set up in FME Flow. So we now need to incorporate these new attributes in our workflow. So with parameters, it's really important to validate user input. So we can add an attribute validator just to check that they set a region value since it is required. A more complete validation might check it against all the Excel names, but we'll leave that for next time. So then the attribute manager will just replace the value with an asterisk if they want all regions. And in our Excel reader, just updated the path to have that flexibility. And then between our feature readers, let's throw in a tester. It's not ideal, but it's going to make sure that each location has the requested minimum capacity on our Excel sheets, which don't otherwise support queries. Before finishing, we can't forget about our new 400 status codes for bad parameter values. So we will add an attribute creator that builds those response attributes. So 400 and the message. And we'll connect that to the attribute validator. So now let's test it. Templates are a lot more useful when you have parameters. We can set a value for the minimum capacity, say 3, and set a value for the region. We can also save that sample for future use. Let's give it a descriptive name. And select a sample instead of just a plain template. There it is. So we'll run it. And we can confirm in our output file that we have a 200 response and a much shorter array that meets our client request. So let's publish the workspace back to FME Flow. And back in our Workspaces tab, you can check that status again, just do a quick refresh. It means authoring now, and now it is assigned. So let's open the Swagger documentation to confirm all the expected responses. So we'll start with a specified region. And since minimum capacity is optional, we won't put that in yet. So here are our regional results. Everything looks good. Next request, we can try with minimum capacity. We should get a shorter list of locations. Yep, looks like it's further filtered. And now let's try to do a request with something like a silly value we know won't get results. So let's try 1,000 minimum capacity, see what that does. Now we get an expected 204 no content response. So there you have it. We've walked through the process of updating our facilities endpoint. We now have 2 new parameters that make our endpoint more flexible and user-friendly, while still handling errors cleanly. That also happens to be everything you need to know to create the Data Virtualization API that powers the dashboard we showed in our first demo. And this being a very basic example that I threw together in an afternoon, I can't imagine what you guys will come up with this. There's still a lot beyond what the demos covered, and we can't test every single feature today, but I'll give a quick overview of what's available. So you can build endpoints that handle file uploads and downloads. This will be really useful for generating documents or exporting data. I'm really looking forward to trying this out with our new PDF tools. Caching stores responses, so the API doesn't have to run a request each time. It speeds things up and reduces load, which helps our API handle more traffic. Job expiry clears out stalled or long-running jobs. This keeps queues from backing up. And for heavier or time-sensitive workflows, definitely consider using something like a dedicated queue or CPU engines to manage spikes. Some requests can potentially take a really long time, and regular API calls, synchronous, can time out or clog up your queues. So asynchronous processing will help reduce pressure. Instead of a regular workspace response, the client gets a request ID back from the API. They can then call the status endpoint to check on their request, all while processing continues on FME Flow in the background. Finally, the client can call the result endpoint to get their intended result. So before we finish, a few quick notes on debugging. It works like any other workflow. You start with the job log. Most of your issues are going to show up there. And with APIs, bad input is one of the most common problems. So it helps to validate requests early and return clear error messages. FME Flow also returns some standard HTTP codes that can help you with your troubleshooting, but don't rely on them entirely. It's better to set up your own checks and balances. So that wraps up our presentation on data virtualization. I hope you all liked what you saw, and I'm going to hand it back to Don to wrap it up.
Great. I mean, wow, that was amazing, Sanai. Really good. And you can just see step by step how to do it. form and flow, you're really ready to go. So yeah, give it a try. And of course, reach out to us as you're building these things. Let us know what's working for you. Let us know what you'd like to see next, because of course, nothing's ever finished, and that's what helps drive us forward. So thanks so much, Sanai. That was really great. Everything we need to know about getting started with data virtualization. So yeah. And so now, so the conclusion, data virtualization, as you saw, now you have real-time access for your data to applications. So I can't imagine trying to do what Sinai did before, without data virtualization. Some people did build data virtualization layer with old FME, but of course they couldn't control the HTTP code status, which is just foundational. So, and they didn't have caching, and it was much more clumsy. So this is really, really great. And a little bit about SAFE, of course, if you've never heard about us, we've been doing this for 30 years. You can see our security authentication on the side. We're based in Canada, 25,000 organizations around the world. So we have, if you're using FME or you're about to use FME or in great company, our community is just amazing. Ask questions there. You'll just meet so many great people. Reach out to us. We love supporting you. So also support at safe.com. It's really great to do things like that. So I think I pass this off to you, Elizabeth.
Yeah, thanks, Don. Yeah, so in terms of resources to help you get started, data virtualization is now available as of 2025.1 beta. The release there has it available. So we highly recommend you check it out and download the newest release. We also do have a tutorial for getting started with data virtualization. I'm not sure, Sinai, if you had any notes on that one, but it looks like a fantastic resource. I did take a look at it myself briefly.
Yeah, it walks through all the same steps that we covered here, so you can follow along and build it yourself. So yeah, definitely check that out.
Yeah, nice.
Awesome. And I'll drop that in the chat as well so people can access that easily. With other resources here at SAFE, I'd like to highlight our FME Academy, guided learning at your fingertips. We do have free instructor-led training offered there. Our webinars, lots of upcoming and on demand. We just posted a few new ones, so we recommend you check those out, safe.com/webinars.
It's a treasure trove of good stuff. Yeah, lots of stuff with clients as well. So you'll see what real users are doing with FME. So yeah. Really great.
Fantastic. In terms of next steps as well, please do get in touch with us to chat anything data, info@safe.com. We'd love to help you get started. And our FME Accelerator course I'll highlight as well in case you are newer to FME. This is a great place to learn the basics. It's 90 minutes and completely free of charge. Our community badge code today. You'll see it on the screen there, and I'll also drop that in the chat. So if you're a member of our community and you like to redeem those badges, this is just as a thank you for joining us today. And if you haven't heard of our community before, we highly recommend you check it out. It's a great place to both network with other users and experts alike. With that, we do have 12 minutes here for some questions. We got a bunch of great questions that came in. So I'll invite our presenters and Rylan as well, if you'd like to join us on stage, and we can take a look through together.
Awesome. Yeah, thanks, Elizabeth. Thanks, Sinai. And yeah, so lots of great questions. We answered a lot of them. I'm curious about, there's one fundamental one that I want us to chat about, and that was the versioning. Is there versioning support anywhere at this point?
Yeah, that's a great question. So when you're creating your API, you're able to set versioning. You can run multiple APIs on the same instance of FME Flow. So if you need to support multiple versions of the API, you can do that. Love to hear more about how we can make it easier for you if this is going to be one of your requirements.
Yeah, so you can have a V1 and a V2, no problem.
Yep.
Perfect. Yep. Yeah. And then some good questions too about being, as the administrator, being notified when things don't work with 500s and things like that. So yeah, and please do. I mean, this is great. We take all these notes, and this is data virtualization is not done. So really, give us the feedback on what you would like. There is one that somebody noticed, I guess I've been playing around already, that caching ignores parameters, and that is a bug. We will fix that. Remember, it is in a beta, so if you find something that you go, wow, that's wrong, let us know, because we have time to fix things. So yeah, or something you just think we really missed, but we think we got most of the things right for a first release. We think it's pretty good. So yeah. Any favorite questions for you, Rylan?
Yeah, I like some of the questions. People who must already be using FME Flow, they must be managing Flow instances, and they're already starting to think of how am I going to be splitting up my processing power between what I have set up and these new data virtualization APIs. So when you have each API will support setting a queue, and now we have an engine management feature page where you can manage queues. You can have engines automatically assigned to them. So that would be the end, is through queues.
Yeah, so CPU time engines will be really useful, because of course, if you have one of these and it's supporting your business, people probably aren't working at 3 in the morning, but they might be really, really busy at 10 in the morning. So yeah. How about you, Sanai? Any questions that stood out for you?
Yeah, I guess I just want to add a comment to those questions about error handling and getting notifications and stuff. Like I said during the debugging slide, it really isn't too far outside of what you already know about debugging in FME Flow. So something I wish now in retrospect that I added to the demo was going to that job history page and checking out the log file for your request. All the errors that you're familiar with are probably going to be what you see. Maybe your database is down and there's a connection error or something like that. It's going to feel really familiar when you get into that debugging process. And of course, we can set up automations and custom workflows for setting up those notifications to let you know when something does go wrong. But yeah, we appreciate all that feedback that we're getting as well on how to improve that process.
And Kevin Weller just asked a really great question. So, he wants to build a REST API, but he wants to use a database schema as the starting point. So that's a great one. And I'm just going to be really honest, hadn't thought about it till you asked it. But it's a great question. And yeah, wouldn't it be nice if you could point at some databases and then be able to generate an OpenAPI spec from that? And maybe we need an OpenAPI. Anyway, yeah, that's a great question, and really like it. Yeah,
I love
because
that.
that's one of the use cases, isn't it? Where you might have a database table with 10 columns and you want to share 6 of them, but 4 you can't share. And so now with DV, you could really make that easy. So you can do it now, but of course, what Kevin wants is just for us to make it easier. So yeah.
One thing I might suggest trying is plugging your table information into OpenAI or another AI client and getting it to generate your OpenAPI spec file for you, or seeing what it can do. I've played a little bit around with that, and you can get really great results.
Well, there you go. AI to the rescue. So yeah, wouldn't it be great if you could use the AI assist in FME to do that?
It's a thought.
It could happen. Yeah, it could
Yeah,
happen.
you can get fun with it if you have a token for the OpenAPI caller, or you can talk to your own AI.
Yeah. So great. Yeah. So lots of great questions. And please do, after you start playing with it, like, we don't think we hit everything, but we think we've made a really great start. And I'm not kidding when I say we thrive on feedback, because then we know, because there's a lot of them around monitoring and endpoints, and it's no secret for anybody who went to the peak for the next while on Flow. One of the things we're really working on is that dashboard for admins to see what's going on, right? So particularly in large ones, you need to know, what the heck is FME Flow up to? When are my resources getting constrained? Because on an endpoint, there's just some calls they can't wait, right? So anyway, lots of interesting, yeah. So yeah, but I think it's safe to say. Oh yeah, how much does this cost, Ryland? Are we, you know, like every other vendor, when a new feature comes out, they would charge, you know, like a huge number to, you know, so if I'm a Flow user and I upgrade, how much do I got to pay to get this new feature?
Nothing extra, Don. Nothing.
It just comes with it. Amazing. So there you go. So yeah. So yeah, I'm glad people appreciate my humor, because everybody who works with me knows I really appreciate my humor. So yeah, so that's important. As we build things in FME Flow, we don't charge extra for it, right? And because at the end of the day, we know you're going to get more value from Flow, and you know, obviously, you know, all of a sudden you have applications hitting Flow. Well, that's a load on the CPU, so you need more engine time. CPU engine time, I think, is really going to be important here, because you're only paying for the work being done. And yeah, so there you go.
Amazing.
Mm-hmm.
Right. Okay. I also would like to mention, while the team's maybe taking a final look over our questions, I did get a couple messages privately asking about the recording. So just to note, once the webinar recording is available, we will send everyone out an email, or you can always check on our webinar page. We post it there too. But yeah, we'll send out an email to all registrants once it's up.
Yeah, because there was a great comment that, you know, as we really boiled this down, but we still wanted to fit it in 1 hour. So Sanai is an FME expert, so she goes really quickly. She's been playing with this. But the nice thing about the recording is then you can stop and back up, you know, like we all do when we're using YouTube to try to retile our bathroom or something, you know? Yeah.
The tutorial series also has a few other scenarios that you can work through. So we have post requests, we have handling geometry, we have some tutorials coming for using generative AI with data virtualization. So keep your eyes out on that series, and there'll be new stuff rolling out every day.
Yeah, and we have one customer, T. Baker Smith, they're using FME Realize, and so what they're doing is they're building a DV layer underneath their FME Realize workspaces. So they're actually splitting the work across, you know, layers in FME Flow, because then they can make their data or FME Realize workspaces so much easier, and they get caching, right? So they're making them easier, but also they're getting the advantage of caching underneath. So yeah.
Awesome.
Great.
Okay, it looks like we've gotten to all our questions, but is there any others that the team wants to address? No?
Maybe a good question. What's the best way for someone to share their feedback with us about what they like, what they don't like with data virtualization?
Oh, that's a good question.
Yeah, that's a good one. I would suggest, at least on the end of the webinar, if you have any initial feedback or other ideas past what you've put in the chat already, we do also have a webinar survey, so feel free to drop anything in there. We take a detailed look over that as well.
Yeah. In the community, we have joined the community. You'll find lots of, and the great thing with the community is if you ask a question there, in addition to what Elizabeth, no matter how you reach out to us, we'll get back to you. But in the community, you'll be able to chat with others in the community as well as SAFE, because we are a big part of the community. And and ideas, I guess. Rylan, anything else come to mind, Rylan?
No, I think FME community is probably the best spot. The whole product management team, all of our customer success, we monitor that space. We look for really interesting threads. You can tag us. So I think that'd be a great place.
Yeah. And tell us what you don't like. I know, like, you know, like I was at the Snowflake conference, and I had somebody come up, a user, and I said, tell me what we can do for you. And she says, I would like to see automations be able to be version controlled in Git. And then I'm like, oh, this is great, right? And then she started to really warm up, and i.e. share other things. And when she left, I said to the other folks at the booth, that was golden, right? Because I left with a few things that we can make it better, and that's what it's all about. So, you know, she made it clear as she left, oh no, don't get wrong, I'm a happy FME user. I'm like, no, this is great. We can't make it better in a vacuum. So, you know, yeah. So there you go. So please do, if you see us at a trade show, go away, write down all your wants, and then come and, you know, unload on us. It's great. That's why we're there. Yeah.
Amazing. Okay, well, we are almost at the top of the hour here, so I do want to extend a huge thank you to our whole audience for joining us today, and for Sinai and Dawn and all your time preparing today's content, and Rylan for your support with questions. We really appreciate it.
And thank you, Elizabeth. You are the cornerstone of this whole webinar thing, and you just make it so easy on us, and you do such a great job. And you're amazing on stage too, for those who saw you.
My pleasure. Thanks, Dawn. I appreciate that. All right, awesome. Well, hope you all have a great rest of your day. We will leave things running a couple minutes longer. Feel free to keep chiming in questions, and we will get to them by email if we don't get to them during the webinar. Thanks everyone for joining. Bye for now.
Thanks everyone. Take care.